Welcome to this comprehensive lecture on Git and GitHub. Over the course of this session, we are going to do a thorough revision of everything from the very first day, covering what Git actually is, how it differs from GitHub, how to set up a local project, how to connect it to a remote server, and how teams collaborate using pull requests. So let's get started from the very beginning.
The very first and most important distinction to understand is that Git and GitHub are two completely different things. Git is software. It is a program installed on your local computer where you run commands, things like committing your work, creating branches, merging branches, and stashing changes temporarily. All of that is Git. GitHub, on the other hand, is simply a server on the internet. It is a place where you store your Git repositories so that others can access them. And GitHub is not the only option. There are alternatives like GitLab, Bitbucket, Gitea, and Azure repos. They all do the same job. GitHub is just the most popular one.
Let's talk about what Git commands actually do. Think of your project files going through a journey. When you first create or modify a file, it sits in the working directory. It is untracked, like someone standing outside an airport. When you run git add, you move that file into the staging area. Think of it as the waiting room. When you run git commit, you lock that snapshot into your local repository. The file is now on the plane. And when you run git push, you send it up to the remote server, like GitHub. Other important commands include git branch for creating branches.
So why do we even need GitHub? Imagine you are working on a project on your local computer. Only you can see it. Now suppose you want a teammate, maybe someone in Kathmandu, to also work on the same project. Your local computer cannot share files directly with theirs over the internet. That is where GitHub comes in. You push your project to GitHub, and now anyone you give access to can pull it down to their own computer and contribute. GitHub is the bridge that makes team collaboration possible.
Now, let's walk through setting up a local project from scratch. First, you create a project folder. In this example, it is called Git project. You open it in VS Code by typing code dot in the terminal. At this point, if you run git status, Git will tell you there is no repository here yet. So you run git init, which creates a hidden .git folder behind the scenes. You do not need to see or touch this folder. Then you create your files. In this example, an index.html file is created with a header, a main section, a footer, and a navigation bar with links for home, services, and contact. Once a logical unit of work is done, like finishing the navbar, you stage it with git add and then commit it with git commit-m followed by a meaningful message like add index page. That is your first commit done. Before we push anything to GitHub, let's understand branches. When you initialize a repository, you start on a default branch, often called master or main. In this example, the instructor renames it to stable to represent the production-ready version. Think of it this way. The stable version is what end users see. It must always work. The beta version is nearly ready and tested internally. The alpha version is the earliest stage, shared only among developers. By renaming the branch to stable using git branch-m stable, we are making it clear that this branch holds the clean, working version of the project. Now that we have a local repository with at least one commit, we need to create a matching repository on GitHub. Log into your GitHub account, click the plus icon, and select New Repository. Give it a name, in this case, Git Project. Then choose the visibility. If you set it to public, anyone in the world can view your project. It becomes open source. If you set it to private, only you and the collaborators you explicitly invite can see it. For this demo, it is set to public. Click Create Repository, and GitHub will immediately show you a set of instructions for connecting your local repository to this new remote one. To connect your local repository to the GitHub remote repository, GitHub provides you with the exact commands. Since we already ran git init and already made our commit, we skip those steps. The key command is git remote add origin, followed by the GitHub URL. This tells your local Git where the remote server is, and we nickname it origin. Then we push our local stable branch up to GitHub. After this, your local project and the GitHub repository are linked. Any changes you make locally can be pushed up, and any changes on GitHub can be pulled down. Now, let's talk about the pull request workflow. This is how teams actually collaborate. A team member, say someone in Kathmandu, starts by pulling the latest code from GitHub using git pull. This ensures they are working from the most up-to-date version. Then they create a new branch for their specific task, for example, service page update. They switch to that branch, make their changes, commit them, and push the branch up to GitHub. At this point, GitHub detects the new branch and shows a pull request notification. The project owner, the person managing the repository, can then review the changes on GitHub before deciding to merge them into the stable branch. Once a pull request is on GitHub, the project owner has two ways to handle it. The first way is to merge it directly on GitHub. Just click the merge button in the pull request interface. The second way is to pull the branch down locally, review the code on your own machine, merge it using git merge, and then push the result back up to GitHub. Both approaches are valid. In real-world teams, the common practice is to merge on GitHub because it keeps a clean record of who reviewed and approved what. After merging, the feature branch is no longer needed and should be deleted, both locally and on the remote. After a branch has been merged, it is good practice to delete it so your repository stays clean and organized. To delete a local branch, you use git branch-d followed by the branch name. To delete the remote branch on GitHub, you use git push origin-d followed by the branch name. One important point, only one designated person, usually the project lead or repository owner, should be managing remote branch deletions. If everyone on the team starts deleting remote branches without coordination, things can get messy very quickly. The goal is to always keep just the stable branch active and create short-lived feature branches only for specific tasks. One thing that often confuses beginners is the difference between local and remote branches. When you see a branch name prefixed with origin/, like origin/stable or origin/contact page, that means it is a remote branch living on GitHub. When you see a branch name without that prefix, just stable or contact page, that is a local branch on your computer. To see only your local branches, run git branch. To see only remote branches, run git branch-r. To see all branches, both local and remote, run git branch-a. Understanding this distinction helps you know exactly where your code is at any given moment. Let's walk through a complete real-world example, adding a contact page to the project. The team member starts by running git pull to make sure they have all the latest changes. Then they create a new branch called contact page and switch to it. They create a contact.html file with a header, main section, footer, and contact details like an address. Once the work is done, they stage everything with git add, commit with a clear message like add contact page, and push the branch to GitHub. In a real team, they would then send a message on Slack or a similar tool saying the pull request is ready for review. The project owner reviews it, merges it into stable, and then both the local and remote feature branches are deleted. Clean, organized, and collaborative. Sometimes you will notice that deleted remote branches still appear in your local branch list. This happens because your local Git keeps a cached reference to remote branches. To clean this up, you can run git fetch-p. The -p flag stands for prune, which removes any local references to branches that no longer exist on the remote. It is also worth understanding that git pull is actually two commands in one. It runs git fetch to download the latest changes, and then git merge to integrate those changes into your current branch. Knowing this helps you understand what is happening under the hood when you pull. Let's also clarify the version naming convention that was mentioned. When a software project is in its very early stages, full of bugs and incomplete features, it is called the alpha version. This is shared only among the development team. When the project is mostly feature complete but still being tested and refined, it becomes the beta version, shared with a limited group of testers. When everything is polished and ready for the public, it becomes the stable version. This is what real users interact with. In Git, you can represent these stages as separate branches or as tagged releases. The instructor uses stable as the main branch name to make this distinction explicit. Here's a quick reference of all the key Git commands we have covered. Git init sets up a new local repository. Git status shows you the current state of your files. Git add stages files for committing. Git commit saves a snapshot of your work. Git branch creates a new branch, and Git switch moves you to it. Git merge combines a branch into your current one. Git push sends your work to GitHub, and Git pull brings the latest changes down. To delete a local branch, use git branch-d. To delete a remote branch, use git push origin-d. Git branch-r lists all remote branches, and git fetch-p cleans up stale remote references. Keep this list handy as you practice. These commands form the backbone of your daily Git workflow. So up until this point, everything we've been doing has been happening only on our own local computer. But what happens when you need to collaborate with someone else? Say, a developer sitting in Kathmandu. Your local machine simply can't share code with them directly. That's where the internet comes in, and more specifically, that's where GitHub comes in. GitHub is essentially a place where you take your local project and host it on a remote server. So you have your local repository on your machine, and then you have a remote repository on GitHub, accessible to anyone you give permission to from anywhere in the world. Before we go further, let's clarify some terminology. In everyday computer language, we call it a folder, but in Git's language, that same folder is called a repository, or repo for short. So when you hear someone say push to the repo or clone the repo, they're just talking about a project folder, one that Git is actively tracking.
It's the same concept, just with a different name in the Git world. So how do you actually connect your local project to GitHub? You use the command git remote add origin followed by your repository's URL. Let's break this down. The word origin is just a nickname, a shorthand label for your remote server. The URL that follows is the actual address of your project on GitHub, which includes your username and your repository name. When you run this command, you're essentially telling your local Git, hey, my remote server is located at this address and I'm going to call it origin. This is a one-time setup step for each project. Now let's talk about two of the most fundamental operations in Git collaboration, push and pull. Think of it this way. When you push, you're sending your local work up to the remote server on GitHub. You're uploading your changes. When you pull, you're doing the opposite. You're bringing changes down from the remote server to your local machine. You're downloading updates. Push goes from local to remote. Pull goes from remote to local. These two commands are the heartbeat of any collaborative Git workflow, so make sure these directions are crystal clear in your mind. When you're ready to push your local work to GitHub for the first time, you use the command git push-u origin followed by your branch name, in this case, stable. Let's unpack each part. Git push is the core command. The -u flag stands for upstream. It tells Git to remember this remote location, so that next time you can just type git push without all the extra arguments. Origin is the nickname for your remote server that we set up earlier, and stable is the name of the branch you're pushing. Once you run this, you can go to GitHub, refresh the page, and your branch, along with all your files, will appear there. Now let's talk about an important concept in software development, the 3 types of versions. First is the alpha version. This is the earliest stage, used only among developers internally for testing. It's not meant for the public at all. Second is the beta version. This is when you bring the software out to a wider audience for public testing. The key thing about beta is that the features you see there might or might not make it into the final product. You're gathering feedback to decide. Third is the stable version. This is your production-ready release. Everything has been tested, confirmed, and is ready for real users. Think of stable as what's currently live and working in the real world. So how do you actually bring another developer onto your project? GitHub has a built-in collaborator system. Here's how it works step by step. First, go to your repository on GitHub. Then click on Settings. In the left sidebar, you'll find an option called Collaborators. Click that. You'll be asked to verify your password. Then you can search for someone by their email address or GitHub username and add them. GitHub will send them an email invitation. Once they accept that invitation, they become a collaborator on your project. And here's the critical distinction. Only collaborators can push changes to your repository. If someone is not a collaborator, they can view your public code, but they cannot push anything. This is how you control who can contribute to your project. Now, here's a really important command, git clone. Imagine your local project folder gets deleted or your computer crashes. As long as your code is on GitHub, you can get it back. You simply open your terminal, navigate to where you want the project, and run git clone, followed by the repository's HTTPS URL. Git will download an exact copy of the entire remote repository, all files, all commit history, right onto your local machine. This is also how a new collaborator gets started on a project. They clone the repo, and instantly they have everything that's in the remote repository on their own computer. When you're setting this up for the first time, use the HTTPS link rather than SSH, as it requires less configuration. Let's walk through a real scenario to make this concrete. Suppose you've been working on your project and suddenly your local project folder is gone. Maybe you accidentally deleted it or your computer had to be formatted. Panic, right? Well, not if you've been pushing to GitHub. Your remote repository on GitHub still has everything. You open a terminal, navigate to your desktop or wherever you want the project, and run git clone with your repository's URL. Within seconds, your entire project is back, exactly as it was when you last pushed. This is one of the most powerful benefits of using a remote repository. GitHub effectively acts as your backup system. There are actually 2 commands that bring changes from the remote server to your local machine, git fetch and git pull, and they behave differently in an important way. Git fetch downloads the changes from the remote repository, but it does not automatically merge them into your local branch. It just brings the data over so you can inspect it. Git pull, on the other hand, does both. It downloads the changes and immediately merges them into your current local branch. So if there are conflicting changes between what's on the server and what's on your machine, git pull will attempt to merge them, which could result in a merge conflict. Git fetch is the safer, more cautious option.
Git pull is the faster all-in-one option. Choose based on your situation. Now, let's talk about how branches fit into a real collaborative workflow. When you want to add a new feature or test something new, you don't do it directly on your stable branch. Instead, you create a new branch. For example, if you want to start a beta testing phase, you run get branch beta to create the branch, and then get checkout beta to switch to it. Now, any changes you make are isolated to the beta branch. Your stable branch remains untouched. This is the whole power of branching. Multiple people can work on different features simultaneously, each in their own branch, without interfering with each other or with the production-ready stable code. Once you've done some work on your new branch, say you've added a gallery page to the beta branch, you commit those changes just like normal. Git add, then git commit with a message. Then to push this branch up to GitHub, you run git push origin beta. After refreshing GitHub, you'll now see two branches listed in your repository, stable and beta. Each branch represents a separate line of development. Your stable branch has the production-ready code, and your beta branch has the new features being tested. This is how professional teams manage multiple versions of a project simultaneously.
GitHub lets you control which branch is shown by default when someone opens your repository. This is called the default branch. To change it, go to your repository settings, then General. Scroll down to find the default branch section. You'll see a pencil icon. Click it. Then choose Switch to another branch. Select the branch you want as default, for example beta, and click Update. GitHub will ask you to confirm by clicking I understand. After this, anyone who visits your repository will land on the beta branch first. You can switch this back at any time, for example once your beta testing is complete and you want stable to be the default again.
Mistakes happen. You might accidentally create a branch with a typo in the name. For example, you meant to create a branch called Alpha, but you typed Alpa instead. No problem. You can rename the current branch using the command git branch-m followed by the correct name. So git branch-m alpha would rename whatever branch you're currently on to alpha. This is a simple but handy command to know, especially when you're working in a team, and branch names need to be clear and consistent. Always double-check your branch names before pushing them to the remote repository. Here's where things get really interesting in team collaboration. Imagine two developers both branched off from the same base code. Developer A, working on the alpha branch, added a login page. Developer B, working on the beta branch, modified the hero section text. Now both branches have changes, and they both diverged from the same starting point. When you try to merge these two branches together, Git has to figure out how to combine both sets of changes. This is called a three-way merge. Git looks at the original base, the changes in branch A, and the changes in branch B, and tries to combine them intelligently. If the changes are in completely different parts of the code, Git can merge automatically. But if both branches changed the same lines, you get a conflict. A merge conflict happens when two different branches have both made changes to the exact same part of the same file. Git is smart enough to merge changes automatically when they're in different places, but when two people edited the same line, Git doesn't know which version to keep, so it stops and flags it as a conflict. Git will actually mark the conflicting sections inside your file with special symbols, showing you both versions side by side. You then have to manually decide which version to keep, or even combine both. Once you've resolved all the conflicts, you complete the merge with a commit. Conflicts can feel intimidating at first, but they're a normal part of collaborative development, and Git gives you all the tools to handle them. When your project is ready to be officially released, you don't just push code, you create a release with a tag. Think of it like a factory putting a label on a finished product. In GitHub, you go to the Releases section of your repository and click Create a new release. You then create a tag, something like v1.00, which marks this exact point in your project's history as version 1. You give it a title, like Stable Version, and write release notes describing what's included in this version. Then you publish it. Now, anyone looking at your repository can see this as the official version 1 release. Tags are incredibly useful because they let you go back to any specific version of your project at any point in the future. Let's be very clear about permissions, because this is something that trips people up. When your repository is public, anyone in the world can view your source code and even clone it to their machine. But that does not mean they can push changes to it. Only people you've explicitly added as collaborators have push access. A non-collaborator can look at your code all they want, but the moment they try to push, GitHub will reject it. This is a critical security feature. It means you're always in control of who can actually modify your project. So when you're building a team project, make sure you add your teammates as collaborators. Otherwise, they'll be stuck just watching. GitHub gives you a really powerful visual tool to track collaboration, the network graph found under the Insights tab of your repository.
This graph shows you a timeline of every branch and every commit made across your entire project. You can see exactly who made which commit, on which branch, and on what date. You can see when branches were created, when pull requests were merged, and how the entire history of your project flows. This is incredibly useful for team leads and project managers who need to understand what everyone has been working on. It's also great for debugging. If something broke, you can trace back through the commit history to find exactly when and where the change was made. Here's an important best practice that was emphasized. Commit completed units of work, not every tiny change. Think of a commit as a checkpoint that says, I finished this one thing. You can use the staging area to collect your changes as you work, but only actually commit when a logical piece of work is done. For example, don't commit after writing one line of HTML. Commit after you've finished building the entire login form. And always write a clear, descriptive commit message. Instead of update stuff, write something like add login page with email and password fields. Good commit messages make your project history readable, trackable, and much easier to debug later, especially when you're working in a team and others need to understand what you did. Let's bring everything together into one clear picture of the full collaborative workflow. You start by creating a repository on GitHub and connecting your local project to it with git remote add origin. You push your initial code up with git push. You add your teammates as collaborators through the settings page. Each collaborator clones the repository to their own machine. Everyone creates their own branch for the feature they're working on. They work, commit, and push their branch to GitHub. When they need to get updates from the server, they use git pull or git fetch. When features are ready, branches get merged, and any conflicts get resolved manually. Finally, when everything is stable and tested, you tag a release and publish it. This is the real-world workflow used by professional development teams every single day. Picking up from where we left off, once you have a local Git repository on your machine, the natural next question is, how do you share it or back it up? That's exactly where GitHub comes in. GitHub is essentially a server, a remote location on the internet where you can store your local repository. So your local project, which lives in a .git folder on your computer, gets pushed up to GitHub, and it becomes what's called a remote repository. From that point on, your project is accessible online, and you can push changes up or pull changes down between your local machine and that remote server.
Once your project is on GitHub, you get to decide who can see it. You have two options, private or public. A private repository means only you, or people you specifically invite, can view the code. This is exactly what you'd use when working on a commercial project for a company. If a company is paying you to build their app, that source code is confidential. It's not meant for the public, so you keep it private. On the other hand, a public repository is visible to the entire world. Think of it like a YouTube video. Private means only you or selected people can watch it, but public means anyone on the internet can see it. Open source projects are always public, because the whole point is that everyone can read, learn from, and contribute to the source code.
Now let's talk about branch management. When you're working in a team, each developer works on their own branch, an isolated copy of the codebase where they can make changes without affecting anyone else's work. There are two main ways to create a branch. The first is simply running git branch followed by the branch name. For example, git branch about to create a branch called about. The second and more modern way is git switch -c about, where the -c flag stands for create. You might also come across git checkout -b, but that command is considered outdated now, so it's best to avoid it and stick with git switch -c.
Here's how the real-world team workflow looks in practice. Imagine a team lead assigns a developer, let's call him Amit, the task of creating an About page. Amit creates a new branch called About on his local computer. He works exclusively on that task, creating about.html with a header, main section, and footer. He doesn't touch index.html or any other file that wasn't part of his assignment. Once his work is done, he stages the changes with git add dot and commits with a message like add about page. His job on that branch is complete. The key discipline here is you only work on what you were assigned on your own branch, and you don't interfere with anyone else's work. When Amit first joins the project, he clones the remote repository using git clone, followed by the repository link. This downloads the entire project, including all existing files like index.html, onto his local machine. After he finishes his work on the About branch, he doesn't just merge it himself. In a real company, there's a designated person, usually a team lead or a quality assurance engineer, whose job is to review all code before it gets merged into the main branch. Amit sends what's called a pull request, which is essentially saying, my work is done, please review it and pull it into the main project.
Not everyone on the team has merge permissions. That's an important discipline to understand. Now, let's talk about one of the most important concepts in collaborative Git work, conflicts. A conflict happens when two different branches have made changes to the same part of the same file, and Git doesn't know which version to keep. Here's a concrete example. Imagine the original file has one line, hello world. Developer A goes into their branch and changes the spelling of world, maybe fixing a typo. Meanwhile, developer B, working on a separate branch, adds a new line below hello world. When developer B's branch is merged, there's no conflict. They only added something new. But when developer A's branch is merged, Git sees that the same original line was changed in two different ways, and it raises a conflict. There are two types of merges you'll encounter. The first is a fast-forward merge. This happens when your new branch only adds content. It doesn't change any existing lines. Git can simply move the branch pointer forward without any conflict. Clean and simple. The second type is a three-way merge. This happens when multiple developers have made changes to the same lines in the same file. Git has to compare three versions: the original common ancestor, your version, and the incoming version. This is where conflict lies. In a team environment with multiple developers pushing code, three-way merges are very common, and conflicts are something every developer will face regularly.
When a conflict occurs, Git marks the conflicting section directly inside the file using special markers. You'll see less than head, that's your current branch's version of the line, then a line of equal signs as a divider, then the incoming version from the branch you're merging, followed by greater than branch A. Your job as a developer is to look at both versions and decide which one is correct. Should you keep your version, keep the incoming version, or keep both? Modern code editors like VS Code make this easy. They show you buttons to accept current change, accept incoming change, or accept both changes. You click the right option, save the file, and the conflict is resolved.
Here's another very practical scenario you'll face in real development. You're in the middle of working on a feature. You've written some code but haven't finished it yet, so you haven't committed. Suddenly, your team lead messages you, stop what you're doing and fix this urgent bug on a different branch right now. The problem is, you can't switch branches with uncommitted changes sitting in your working directory. Git will either block you or overwrite your work. And you can't commit either because your work is half done and committing incomplete work is bad practice. The solution is Git Stash. Stash saves your in-progress work to a temporary holding area, cleans your working directory, and lets you switch branches freely. You go fix the bug, commit it, come back to your original branch, and run Git Stash pop, and your unfinished work comes right back, exactly as you left it. The last major concept here is Git rebase. Imagine you created a branch from main and started working on your feature. While you were working, someone else pushed new commits to the main branch. Say they added a Johnny Johnny line to the file. Now your branch is behind. It was created from an older version of main. Rebase lets you update the starting point of your branch to include those new commits. You run git diff branch A branch B first to see what's different between the branches. Then, while sitting on your feature branch, you run git rebase branch A. Git replays your commits on top of the latest version of the base branch. This can also cause conflicts. If the new commits from main change the same lines you changed, you'll need to resolve those conflicts the same way as in a merge.
It's worth being clear about when to use merge versus rebase because they're easy to confuse. When you merge, you're typically on the main branch and you're pulling in a feature branch. You're combining histories. When you rebase, you're always on your feature branch. You're saying, update my branch so it starts from the latest version of main. A critical rule, never run rebase from the main or master branch. Always be on your feature branch when you rebase. Rebase gives you a cleaner, more linear commit history, while merge preserves the full branching history. Both are valid. Teams choose based on their workflow preferences. Before moving on, there's one golden rule that ties everything together. A commit should represent one complete logical unit of work. Don't commit just because you've written a few lines. Don't commit half-finished features. If you commit incomplete work and someone tries to merge your branch, it creates messy conflicts and broken code in the shared codebase. The discipline is simple. Finish your assigned task completely, then commit. If you get interrupted mid-task, use Git Stash to save your progress temporarily. This habit of clean, complete commits is what separates professional developers from beginners, and it's what keeps team projects running smoothly. Now let's look at something very practical, how to share your project as a live website using Netlify. Netlify is a free hosting platform that works directly with GitHub. It's perfect for static websites, meaning HTML, CSS, and JavaScript projects like portfolios. Here's the process. go to netlify.com and sign up using your GitHub account. Once you're in, click Add New Project and choose to import from an existing project. Select GitHub as your source, authorize Netlify to access your repositories, and then pick the specific project you want to deploy. Give your site a unique name. The name becomes part of your URL, something like cookerbiralu.netlify.app. Choose which branch to deploy, typically your stable main branch, and hit Deploy. Netlify builds and publishes your site automatically. Within a minute or two, your project is live on the internet with a real URL anyone can visit.
One important clarification worth making: GitHub is not the only remote Git server out there. You'll also hear about GitLab and Bitbucket. GitLab is popular in enterprise environments and can even be self-hosted on a company's own servers. Bitbucket is made by Atlassian and integrates well with tools like Jira. But here's the key insight. The Git commands you've been learning are exactly the same across all three platforms: git add, git commit, git push, git pull, git branch, git merge. None of that changes. The only difference is where you create your account and what URL your remote repository points to. So once you know Git and GitHub, picking up GitLab or Bitbucket is just a matter of creating a new account.
So let's pick up right where we left off with the concept of repository types. A repository, or repo, is essentially a folder that Git tracks, but there are two kinds you need to understand. The first is a local repository. This is the one you create on your own computer using git init. It lives on your machine and only you can see it directly. The second is a remote repository. This is the same idea, a tracked folder, but it lives on GitHub, on a server that's accessible over the internet. When you create a project on GitHub, that's your remote repo. Both are repositories. Both store your code and history. The only difference is where they live.
Now let's talk about how Git actually works as a workflow. When you run git init, you're starting in what's called the working directory. That's just the folder where you write and edit your code. From there, you move files into the staging area using git add. This is like saying, okay, I want to include these changes in my next save. Then you commit with git commit, which saves those staged changes into your local repository. And finally, when you're ready to share your work, you push it to the remote repository on GitHub. This four-stage flow, working directory, staging area, local repo, remote repo, is the foundation of how Git operates. Now we get to one of the most important concepts in team-based Git workflows, the pull request. So imagine a developer named Amit has been working on a feature. He's done. He's written the code, committed it, and now he needs to get it into the company's codebase. In a real company, you don't just merge your own code directly. Instead, you push your branch to GitHub and send a pull request. A pull request is basically a message to the company saying, my work is done, please pull my branch, review it, and if everything looks good, merge it in. It's a formal review process, not just a technical step.
Let's look at the actual command Amit uses to push his work. He runs git push -u origin about page. Let's break that down. Git push means send my changes to the remote. The -u flag sets the upstream, which links your local branch to the corresponding remote branch so future pushes are easier. Origin is the name of the remote repository. That's the default name GitHub gives it. And about page is the name of the branch he's been working on. So this command takes everything Amit did on his local about page branch and sends it up to GitHub.
Here's a really important rule for working in teams with Git. Only one person should be responsible for merging code into the main or stable branch. If every developer just merges their own code whenever they feel like it, you end up with a mess. Conflicts, broken code, things overwriting each other. So the workflow is, each developer works on their own branch, finishes their task, pushes it to GitHub, and sends a pull request. Then the designated person, the team lead or project owner, reviews the PR and does the actual merge. This keeps the stable branch clean and controlled. Once a pull request has been sent and the work is done, what happens to the feature branch? Well, it's no longer needed. Amit's job was to build the About page. He built it, pushed it, sent the PR. Done. So he can now delete that branch. He switches back to the stable branch using git switch stable, and then runs git branch -d about page. The -d flag stands for delete. After this, if he runs git branch to list his branches, he'll only see stable. The about page branch is gone from his local machine. This keeps things clean. You don't accumulate dozens of old branches that are no longer relevant. Here's something that trips people up. When you delete a branch locally, it doesn't automatically disappear from GitHub. Your local machine and GitHub are separate. So after Amit deletes his About page branch locally, If he runs git branch, he only sees stable. But if he runs git branch -r, the -r flag stands for remote, he'll see that origin/about page still exists on GitHub. The remote branch is still there. This is important to understand. Local and remote branches are managed independently. You have to explicitly delete the remote branch as well if you want it gone from GitHub.
So how do you delete a branch on the remote on GitHub? You use the command git push origin delete about page. Let's read that carefully. You're still using git push, but instead of pushing new code, you're using the delete flag to tell GitHub to remove that branch. You specify origin as the remote and about page as the branch name to delete. After running this, if you refresh GitHub, you'll only see the stable branch. The about page branch is completely gone from the server. This is the cleanup step that keeps your GitHub repository tidy after a feature has been merged.
Now let's look at this from the company's perspective, the person who receives the pull request. In a real company, communication happens through tools like Slack. The developer sends a message saying, "Hey, I've pushed my work and sent a pull request. Please check it." The project owner then goes to GitHub, opens the pull request section, and reviews what was submitted. GitHub is helpful here. It shows you a comparison of what changed, and it tells you whether the merge is safe. If it says able to merge, that means there are no conflicts. No code is fighting with other code. The owner then clicks Merge Pull Request, confirms it, and the About page code officially becomes part of the stable branch.
Once the merge is done on GitHub, the stable branch on the server now includes the About page files. But the project owner's local machine doesn't automatically know about this. The local copy is still the old version of stable, so the owner needs to run get pull. This downloads the latest version of the stable branch from GitHub to the local machine. After pulling, the local stable branch is now up to date. It includes the About page that Amit built. 2 new files come down from the server. This is the sync step. GitHub is the source of truth, and get pull brings your local copy in line with it.
Here's where things get really satisfying. Once the merge is complete and the stable branch on GitHub is updated, Netlify, the hosting platform connected to the repository, automatically detects the change. It starts building the new version of the website. This takes a moment, and then it publishes. Just like that, the live website is updated. You don't have to do anything manually. Netlify watches your GitHub repository, and every time the connected branch gets new code, it rebuilds and redeploys. So the full cycle is developer builds a feature, then gets merged into stable, and the website updates automatically. That's a real professional deployment pipeline. A common question that comes up is, can you use your own domain name instead of the default Netlify URL? The answer is yes, absolutely. By default, Netlify gives you a free subdomain like yoursite.netlify.app. But if you want something like yourname.com, you need to purchase that domain from a domain registrar. The Netlify hosting itself is free. You're just paying for the domain name. Once you have a domain, you go into Netlify settings, use the quick setup option, and add your custom domain there. Netlify will then route traffic from your domain to your hosted site. So the server is free, the domain costs money. That's the distinction.
There was a great question about git stash. Specifically, what happens if you forget to run git stash pop? Let's think about this carefully. Git stash works like a stack data structure. You might have learned about stacks and data structures. Items get pushed onto the top, and they come off the top when you pop. If you stash your changes and then forget to pop them, those changes just sit there in the stash. They don't cause conflicts, they don't interfere with your current work, they're just temporarily stored, waiting for you to retrieve them. So forgetting to pop is not a disaster. Your code is safe, just parked. You can always run git stash pop later to bring it back.
Before we move on, let's briefly touch on something that was mentioned: forks. When you want to contribute to someone else's open source project on GitHub, you can't just push directly to their repository. Instead, you fork it. A fork creates your own personal copy of their repository on your GitHub account. You then clone your fork to your local machine, make your changes, push to your fork, and then send a pull request to the original project. The maintainers of the original project review your PR and decide whether to merge it. This is exactly how open source collaboration works at scale. Thousands of developers contributing to projects they don't own through forks and pull requests.
Picking up right where we left off, let's walk through the core Git workflow step by step. When you run git init in a folder, Git sets up what's called a working directory. Think of this as your active workspace, the folder where you're actually writing and editing your files. Now, from the working directory, you don't go straight to saving your changes permanently. Instead, you first move your changes into what's called the staging area. The instructor describes the staging area as a waiting room. It's a holding zone where you place files before they're officially recorded. To move a file from the working directory into the staging area, you use the command git add followed by the file name.
Once your changes are staged, you then commit them to the local repository. So the flow is working directory, staging area via git add, local repository via git commit. This three-step process is fundamental to how Git tracks your work.
Now let's talk about deleting branches, specifically deleting a branch on the remote repository, which in this case is GitHub. The command to do this is git push origin, followed by the -d flag, and then the branch name. The -d stands for delete. So for example, if you have a branch called OnePage, you would run git push origin -d OnePage. After running this, you go to GitHub and refresh the page to confirm the branch has been removed. Now, the instructor points out something important. Sometimes the branch doesn't delete right away. This can happen if the branch still has an active state, or if there are uncommitted changes associated with it. In that case, you may need to handle it from within GitHub's interface directly, using the delete branch option there. The key takeaway is that after deletion, when you look at your repository, you should only see your stable branches remaining. In this example, just the main stable version.
So why might a branch refuse to be deleted? The instructor walks through a few scenarios here. First, if the branch is currently active, meaning it's the one you have checked out, Git won't let you delete it directly. You need to switch to a different branch first. Second, if there are uncommitted changes on that branch, Git protects you from accidentally losing work. You'd need to either commit those changes or discard them before proceeding. Third, if the branch hasn't been fully merged into the main branch, Git may warn you or block deletion to prevent data loss. The solution in most of these cases is either to handle the changes first and then delete, or to go directly into GitHub's web interface and delete the branch from there. Once the branch is successfully deleted, your repository should look clean, with only the stable, production-ready branch visible. The instructor now uses a really relatable analogy to explain how teams collaborate using Git, specifically using the example of an internship environment. Imagine you're an intern at a company. There's a senior person, let's call him Sir, who oversees the entire project. Then there's Ram, who acts as the team lead or merge manager. And then there's Amit, who is a developer or fellow intern. Now, the senior has said clearly, do not handle Git merges on your own. I will take care of that. So Ram is assigned the responsibility of reviewing and merging all branches. Amit's job, and your job as a developer, is simply to create a branch locally, do your work, and then send a pull request. That's it. You don't merge. You don't touch the main branch directly. You just submit your work via a pull request and Ram, or whoever is the merge manager, reviews it and merges it. This separation of responsibilities is a real-world best practice that keeps the codebase stable and prevents accidental overwrites.
Continuing with the same scenario, the instructor now shows what happens when a new feature needs to be built. In this case, Amit is asked to create a service page for the website. So what does Amit do? He creates a new branch specifically for this feature. The command is get switch C service page. The C flag means create, so this single command both creates the new branch called service page and switches Amit into that branch immediately. From here, Amit works on the service page entirely within this branch. He doesn't touch the main branch at all. Once he's done, he'll push this branch to GitHub and send a pull request to Ram. Ram will then review the changes and merge them into the main branch if everything looks good. This is the clean, professional workflow. Every new feature or task gets its own dedicated branch, keeping the main branch stable and untouched until the work is reviewed and approved.
Now, the instructor briefly introduces the concept of open source collaboration, and this is a really important idea in the software world. Open source projects are publicly available repositories on GitHub that anyone can view, use, and potentially contribute to. But here's the thing. What if you want to contribute to a project and the owner hasn't added you as a collaborator? That's where the concept of a fork comes in. A fork is essentially your own personal copy of someone else's repository. You bring that copy onto your own GitHub account, clone it to your local machine, make your changes, and then send a pull request back to the original project owner. The owner can then review your contribution and decide whether to merge it. The instructor mentions a real example, contributing a new feature to a project called Filaments, where a boilerplate was created and submitted. This is exactly how thousands of developers contribute to open source projects every day. No special permission needed to fork, just the willingness to contribute. To make the distinction crystal clear, the instructor compares two types of contributors. A collaborator is someone who has been explicitly added to a repository by the owner. They can clone the repo directly, create branches, and send pull requests within the same repository. A fork contributor, on the other hand, doesn't have direct access to the original repository. Instead, they fork it, creating their own independent copy, make their changes there, and then send a pull request to the original repo. The original owner then decides whether to accept those changes. The instructor is honest here. For beginners, you don't need to worry too much about forks right now. If you're working within a team where you've been added as a collaborator, the standard branch and pull request workflow is all you need. Forks become more relevant when you start contributing to large open source projects or working with code from developers you've never met. It's good to know the concept exists, and you'll naturally pick it up as you grow.
So, picking up right where we left off, let's solidify the complete Git flow from start to finish. You start in your working directory, which is just your project folder on your local computer. From there, you move files into the staging area using the command git add, followed by the file name. The staging area is essentially a waiting room. It holds the changes you've selected and are preparing to save permanently.
When you run git add and provide a file name, that file moves into the staging area. Think of it like placing your luggage on a conveyor belt at the airport. You've decided what's going with you, but you haven't boarded the plane yet. You can also stage all changed files at once using git add dot, which is a very common shortcut. Once your files are staged, you run git commit to save that snapshot into your local repository. This is like officially logging a record of what changed and why. And this is a critical rule. You cannot push your code to GitHub without committing first. The commit is what creates the version history that Git is built around.
After committing, you use git push to send your code from your local machine up to the GitHub server. This is the step that makes your work visible to the rest of the team. The push command takes your committed local history and uploads it to the remote repository on GitHub. So the full flow is working directory, staging area, local repo, GitHub. That's the core Git workflow.
Up to this point, everything we've studied has been local, meaning it all happens on your own computer. We covered staging and committing, creating and switching branches, merging branches, deleting branches, reverting commits, and stashing changes. All of that is purely local Git. Now we're stepping into the next level, pushing to GitHub and working with collaborators.
Now, let's look at a real-world collaboration scenario. Imagine you're the project owner, and you assign a task to a collaborator named Amit. You tell him that a services page needs to be built. In a proper Git workflow, Amit doesn't just start editing the main branch. Instead, he creates his own feature branch, does his work there, and then submits it for review. This keeps the main codebase stable while new features are being developed.
Amit's first step is to create a new branch specifically for the services page. He runs get switch -c service page, where the -c flag means create. This single command both creates the new branch and switches him into it. Now, Amit is working in complete isolation from the main branch. Any changes he makes won't affect the stable codebase until they're reviewed and merged.
Amit now works on his assigned task. He creates a file called services.html and builds out the services page. The structure includes a main tag, a footer, an H1 heading that says Our Services, and an unordered list with 2 items, mobile app development and web development. He's only listed 2 services, but that's the scope of the task he was given. His work is now done locally on his feature branch.
Before Amit can push anything to GitHub, he needs to follow the standard Git flow. First, he stages the file using git add service.html, which moves it into the staging area, the waiting room. Then he runs git commit with a descriptive message. Only after this commit is the work officially saved in his local repository. Before Amit can push anything to GitHub, he needs to follow the standard Git flow. First, he stages the file using git add service.html, which moves it into the staging area, the waiting room. Then he runs git commit with a descriptive message. Only after this commit is the work officially saved in his local repository and ready to be pushed. Skipping the commit means you simply cannot push. Git won't allow it.
Now, Amit pushes his feature branch to GitHub using git push origin service page. Notice that he's pushing the service page branch specifically, not the main branch. This uploads his branch to the remote repository on GitHub, making it visible to the project owner and other collaborators. The main branch remains completely untouched at this point. Now, if typing out git push origin service page feels like a lot to remember, there's a shortcut. In VS Code's source control panel, there's a sync or push button. Clicking that does exactly the same thing as typing the full command in the terminal. The instructor points this out because it's a huge time saver. Both approaches are completely equivalent, so use whichever feels more comfortable.
Once Amit pushes his branch to GitHub, a pull request, or PR, appears on the repository page. GitHub automatically detects the new branch and shows a prompt to compare and create a pull request. A pull request is essentially Amit saying, "Hey, I finished my work on the service page branch. Please review it and merge it into main." This is the standard collaboration mechanism on GitHub.
There's an important distinction to understand here.
Running git pull in your terminal fetches changes from the remote and merges them into your local branch. On the GitHub website, clicking the Merge or Pull button on a pull request merges the feature branch into main on the remote server. Both operations result in code being merged, just from different directions. The instructor emphasizes that these two actions are equivalent in terms of outcome. When the pull request arrives, the project owner, or a designated reviewer, goes to GitHub and compares the code. They can see exactly what Amit added, line by line, in a diff view. If the service page branch looks correct and stable, the reviewer clicks Merge Pull Request to bring Amit's work into the main branch. This review step is what makes collaborative development safe and organized. No one just pushes directly to main without oversight. Picking up right where we left off, the whole point of putting your local project onto GitHub is collaboration. When you have a project where different people need to work on different parts, that's exactly where GitHub's collaboration features come in. Your code moves from your local machine up to GitHub, and from there, multiple collaborators can access it, contribute to it, and work on it simultaneously.
Before you can do anything on GitHub, you need an account. And this is really no different from signing up for any other platform. Think of it like creating a Facebook account. You go to github.com, and GitHub will ask you for the usual things: a username, an email address, and a password. Once that's done, you're in. That's your entry point into the entire GitHub ecosystem.
Now let's walk through what happens when the service page work is ready to be merged. A pull request is submitted with the title Added Service Page Descriptions. GitHub then does its job. It compares the code between the feature branch and the base stable branch. It checks everything, and if the service page looks good and is compatible with the stable branch, it marks the pull request as ready to merge. The description on the pull request says something like service page added to stable, making it clear what this change is about. Once the pull request is reviewed and everything looks good, all the changes are confirmed to be correct and complete, the merge happens. You click Merge Pull Request, then confirm it. At that point, the service page branch is closed, and its changes are folded into the stable branch. The work is done. If you now go and look at GitHub, you'll see the service page is there in the stable version of the project. After the merge, if you look at the repository on GitHub, you'll see two branches listed, stable and service page. But here's the thing, the service page branch has done its job. It's been merged. Keeping it around just adds clutter. In fact, having too many branches in a repository can get really confusing. You start losing track of which branch has what. So the right move is to delete it. Deleting the branch on GitHub is straightforward. You can go directly to the branch in the interface and click Delete. There's even a shortcut right there after the merge is complete. Once you refresh the page, you'll see only one branch remaining, stable. That's exactly what you want. On GitHub, only the stable, production-ready version should live. One clean branch, one source of truth. Now the same cleanup needs to happen locally on your machine. First, you switch to the stable branch using git switch stable. You can't delete the branch you're currently on. Then you run git branch to confirm you have two branches, stable and service page. Since the service page branch has been merged and its work is done, you delete it with git branch-d service page. Here's an important thing to understand at this point. The service page was merged into the stable branch on GitHub, on the server, but your local machine doesn't automatically know about that. If you look at your local project right now, the services page file isn't there. It exists on the server, not on your computer. This is a very common situation in collaborative workflows. The remote gets updated, but your local copy is behind. To fix this, you need to pull the changes down.
The command to bring those remote changes down to your local machine is git pull. When you run it, Git contacts the remote repository on GitHub, fetches any new commits that your local copy doesn't have yet, and merges them into your current branch. In this case, that means the services page file now appears in your local project. Think of git pull as the reverse of git push. Instead of sending your work up, you're pulling the server's work down. After pulling the changes, the service page is now available locally. From here, you can continue working. Stage the changes with git add, then commit with a message like service page to record the state. This keeps your local history clean and in sync with what's on GitHub. At this point, your local stable branch and the remote stable branch on GitHub are aligned. Same files, same history. That's the healthy state you always want to be in when collaborating. So, unlike Git, which works entirely on your local machine, GitHub is a remote service. And to use it, you need to create an account, just like you would on Facebook or any other platform. The process is straightforward. You head over to github.com, and right there on the homepage, you'll see a Sign Up button. Click that, and you can even sign up using your existing Google account if you prefer. You'll be asked for an email, a password, a username, your country, and a recovery email. Once you fill those in and hit Create Account, you're done. Your GitHub account is ready.
Now, one thing that is really important to pay attention to when creating your GitHub account is your username. This is not just a casual social media handle. Your GitHub profile is essentially your professional portfolio. When you apply for a job and show your projects to a company, they will see your GitHub username front and center. So please, avoid usernames like handsome boy, beautiful girl, or anything that sounds casual or silly. Use your real, genuine name or something professional that represents you as a developer. Think of it the same way you'd think about a professional email address on a resume.
Let's take a moment to really understand the relationship between Git and GitHub. Git is the tool you use on your local computer. It tracks changes in your project files and manages your version history. GitHub, on the other hand, is a remote server. It's where your code lives in the cloud. So when you're working on a project, you do all your coding and committing locally using Git. Then when you want to share that work or back it up to the cloud, you push it to GitHub. And if you need to bring code down from the server to your local machine, for example, if a teammate pushed something, you use git pull. These two commands, push and pull, are the bridge between your local work and the remote server.
Let's walk through a real-world scenario to make this concrete. Imagine you're working on a web project, and there's a service page that currently only exists on the server. It's not on your local computer yet. The first thing you need to do is run git pull, which downloads the latest code from the server to your local machine. Now you have the service page locally. From there, you can make your edits. Maybe you're adding new services to the page. Once you're done editing, you go through the familiar workflow. Git add to stage your changes, then git commit with a meaningful message describing what you did, like service page. And finally, you push those changes back up to GitHub so the rest of the team can see them. Now here's where branching becomes really important in a team setting. Suppose your teammate, let's call him Amit, has been asked to update the service page by adding 3 new services: digital marketing, bulk SMS, and boosting services. This is a big task, maybe 3 days of work. In this case, it makes sense to create a separate branch rather than working directly on the main branch. The command for that is git switch -c, followed by a descriptive branch name like service page update. This creates a new branch and switches to it immediately. Amit can now work on this branch independently without affecting the stable main codebase. For small, quick changes, you might not need a branch, but for anything substantial, branching is the right approach.
Once Amit is on his feature branch, he goes ahead and makes the necessary changes, adding digital marketing, bulk SMS, and boosting services to the service page. After making those changes, he stages them with git add, then commits with a clear message like service page update. Notice how the commit message is descriptive. It tells anyone reading the history exactly what was done. Then he pushes the branch up to GitHub using git push origin, followed by the branch name. This sends his feature branch to the remote repository, so it's visible to everyone on the team.
Once Amit pushes his feature branch to GitHub, something important happens. A pull request, or PR, becomes available. A pull request is essentially a formal request saying, hey, I've made some changes on my branch, please review them and merge them into the main branch. On GitHub, after you push a new branch, you'll see a notification or a button prompting you to create a pull request. The team lead or other developers can then go in, review the code, leave comments, request changes if needed, and ultimately approve and merge it. This is the heart of collaborative development. It ensures that no code goes into the main branch without being reviewed first. So what does this actually look like on GitHub? After Amit pushes his branch, if you go to the repository on GitHub and click on the Pull Request tab, you'll see a new entry there, the Service Page Update Pull Request. It shows who created it, what branch it's coming from, and a description of the changes. From here, the team lead can click into it, see exactly what lines of code were added or changed, and decide whether to approve and merge it into the main branch or send it back for revisions. This is the workflow that professional development teams use every single day. Let's bring everything together with a complete picture of the collaborative Git and GitHub workflow. It starts with creating your GitHub account. And remember, use a professional username because this is your portfolio. From there, you either create a new repository or clone an existing one. Before starting any work, you pull the latest code from the remote server. Then you create a feature branch for your task, make your changes locally, stage them with git add, commit with a clear message, and push the branch up to GitHub. Finally, you open a pull request so your team can review and merge your work into the main branch. This 10-step cycle is the foundation of how real software development teams collaborate, and now you understand every single step of it. So let's wrap up with the key takeaways from everything we've covered. First, GitHub is not the same as Git. It's a separate platform that requires its own account, and your username matters because it represents you professionally. Second, Git handles your local version control, while GitHub handles remote collaboration and backup. Third, Git pull is how you bring the latest code from the server to your machine. Fourth, when you're working on a big feature, always create a dedicated branch using git switch-c. It keeps your work isolated and safe. And fifth, pull requests are the professional way to propose and review changes before they go into the main codebase. Together, Git and GitHub form the backbone of modern software development. Master these tools and you'll be working like a professional developer.